Hello everybody, today we are going to see about one of the important application of op-amp. Here the op-amp can be used as a differentiator circuit. What is the meaning of a differentiator? So here you have an op-amp and the output of op-amp will be equal to the differentiation of the input. Here the output of the op-amp will be equal to the differentiated value of the input, Vi. Before going to see about this, we'll see the structure of this differentiator circuit. So this is your op amp and this terminal is the inverting terminal. So here you have the inverting terminal and this one is the non-inverting terminal. This is the non-inverting terminal of the op amp, and to the non-inverting terminal the ground is being connected, and to the inverting terminal here the input voltage is connected through this capacitor. So the input path consists of the capacitor and this path is your feedback path, and this is the feedback path, and in the feedback path the resistor R is connected. As the non-inverting terminal is grounded, this particular node A acts as the virtual ground, and the current IC, that the current which is flowing through the capacitor is flowing from this input side to the virtual ground, and this IR, that is the current which is flowing through the feedback path or the resistor, is flowing from this virtual node to the output side. This is your output side. So using these concepts and the basic, we can now write the equation at node A. We can write the KCL, Kirchhoff's current law. So we know that summation of the incoming current in a particular node is equal to summation of leaving current. So here into this A node, IC current is flowing. So into this A node, the IC current is entering and this IR current is leaving. So we can write this as IC is equal to IR. How do we write the current for this capacitor? Current through a capacitor can be written as IC is equal to the capacitor value into dV by dt. So we can write here as C into D into Vi, that is the input voltage, the difference in voltage, minus this Va divided by this dt. That is equal to IR. What is IR? IR here is, we know it is using Ohm's law, right? So the resistance, the current through the resistance is nothing but the potential difference between 2 points divided by that resistance R. So here it is flowing from this A node to this output side V naught. So it is VA minus this V naught difference in potential, okay, divided by this resistance value R. But actually this VA is nothing but 0. It is the virtual ground, right? So you can rewrite this as C into dVi by dt. That is equal to, here also this becomes 0. So it is minus V naught by R. Actually, what do we need? We need the output. Actually, what do we need? We need the output voltage. So V naught minus V naught by R is equal to C into dVi by dt. V naught is equal to minus R into C into dVi by dt. So here this can be interpreted as the output voltage is equal to minus RC times the differentiation of input voltage. So we got the input voltage being differentiated and then multiplied by this minus RC, so that you will be getting the output voltage. So now this op amp acts as a differentiator. Some more points we can consider. This particular circuit acts as a high pass filter. So how do you say that it acts as a high pass filter? As we have this capacitor which is present at the input side, this will be blocking the DC or low frequencies. That means it acts as the open circuit for DC or low frequencies, and it allows only the high frequencies because of the nature of the capacitor. That's why we say that it is a high pass filter. Okay. But at very high frequencies, this becomes unstable because of the high gain of the op amp, and it becomes an oscillator. That's also you should know. Okay, these are some of the points regarding this op amp as a differentiator. Okay, thank you. Hope you have understood this class.